Welcome to the lesson on data wrangling. In this lesson, we are going to cover how to handle missing value, how to correct data formatting, and also how to standardize and normalize data. So let us start with an introduction to what data wrangling is. It's a process of transforming raw, messy, or unstructured data into a clean structure and usable format. This is a very crucial aspect in data analysis, as raw data is often incomplete, inconsistent, or filled with error, which making it unsuitable for analysis and modeling. So also let's also talk about the importance of data wrangling. It improves the data quality, it enhances analysis, it also prepares for modeling. That's when we want to deploy a machine and a statistical model, and it also saves time because investing time in data wrangling early reduce errors and rework later in the process. So let us start by this lesson by first of all importing our necessary libraries, and that's going to be Pandas. We're going to work with Pandas as PD. Then we import NumPy as NP, and also we're going to import Matplotlib as that's PyLab as PLT. So these are the various libraries we're going to be using. So now let's get our data sets. Remember we're working with the car, the car data set. So let's get this. So let me just open another cell and let me just paste this. So this is the data sets we have been working with so far. And so now let's run this also. Okay, so let's view. So we're going to read from this from our data sets that we are getting. So we're going to use the frame is equals to pd read. This is actually a CSV file, so we use a CSV function, and that's file path. So let's just read this, and let's save it to the variable df. So we can just do something like this. Let's create another cell, so that will be df. So we can see very well that from our data set that there are no headers. Well, Pandas is actually trying to automatically place headers here, but this is not actually the header. So we can actually create headers that we're going to be using. So I'm just going to paste this down here to the screen because I've actually created this before now. So this is going to be a list that's going to be probably our headers. So let me just come here and let me create a cell. Let me come here and create a cell. Then I'm going to just paste this here. So our headers, these are various headers for our that we're going to be using in this data set. So now this is just a list of various information about the car. So we have the symbolism, normalized losses, the numbers of the body style, and the rest. So that's the various headers for each of these columns in our data set. So now we're just going to have to just update this because we're going to be using these headers, this list, to actually place our header. So we just update it and just use the name. It's going to be equals to headers. Okay, so and so once that's run, oh, it says headers is not defined. I think we made a mistake here. Yeah, we made a mistake. We did not actually run this rather. So let's run that, and also let's run this. Okay, so once we run the frame, you could see you're going to see now our headers have actually been inserted to our data frame. So now you can see very well that we have several question marks appearing in our data frame. These missing values, this can actually represent that some missing values may hinder further analysis. So now let us talk on how we can actually identify and how we can actually deal with all of this missing value. So there are various approaches we can take when working with missing data. But for this lesson, we're just going to consider the following. Number one, we're going to identify the missing data. We will deal with the missing data, and also we're going to correct the data formats. So let's talk about identifying and handling this missing value. So as we could see very well now, each of the missing value is actually represented with a question mark. So we are going to replace this question mark with a not a number. Kind of this is what we're going to replace the question mark with not a number. So we're going to convert all of these question marks to the not a number. Now, converting it is essential because it enables Python. That's converting these question marks to not a number is essential because it enables Python numerical library like NumPy and Pandas to recognize and handle this missing value correctly. So we're going to convert all of the question mark in this data sets to a not a number. So we're going to use the replace function to actually achieve this. So let me create a cell, then the data frame replace. Then that's first of all what are we looking out for to replace? So that's a question mark, and we're going to specify we want to replace it with numpy, not a number, and we're going to also include the argument in place true. Okay, so let's view this. So now we take note of this. All of these question marks in this data set will be replaced with the not number. So once I run data frame again, so we could see that all of the question mark was now corrected, or rather was kind of replaced with not a number. Now let's talk about how we can actually evaluate for this missing value. Now the function, there's a function we're going to be working with, that's the isNull function, and that function helps us to identify all missing value. That's the not a number in this our case. So the function, what it does, it outputs a Boolean value indicating whether the value that is passing to it is a missing value. So this is what the function does. So let's first of all give this variable of missing data. Let me say df data frame is null. So let's just print out the missing data. Let's just get the very first 5 records. Okay, there's an error. Okay, they say invalid syntax. Okay, I think I've made a mistake here. I'm supposed to assign this. Okay, so let's run it again. So we could see now that all our records are being represented in the Boolean value true or false. Now, for every single record that is is a missing value, it's going to be represented with the value of true. And every value that is not a missing value, that there's an item in it, it's going to be represented with the value of false. And this is going to be very, very important because we're going to find out from our entire data set all the value, all the items that are actually missing value, all the features that actually has missing value, and the total amount of numbers of missing value they do have. So we could see that we have false, false, false. Normalizing we have true. So wherever true is represented, that is say that particular item is a missing value. So that's what the isNull does. It actually converts its data frame in such a way that every null value is represented with the true Boolean value, and every non-missing value is represented with the false Boolean value. Now we're going to count the missing value for each of the columns. We're going to count it, and we're going to achieve this with the Python loop, the Python for loop. So we're going to use a Python for loop to be able to count the missing values. So we use the for columns in missing data. Columns. Then values. And we convert this to a list. Okay, so this is a for loop. And we're going to first of all print each of the columns. Okay. So I think this should be column, not columns, because this is going to be printing each of the columns. So this should be column. Okay, and that's fine. So we're just going to perform a count of each of the columns, the true and their false values. So we're just going to print missing data, missing data, and we would have access to the columns, each of those columns. Then we're going to use the method value count, counting the values. So whether it's true or it's false. Okay, so let's just place a print statement to be able to demarcate from one column to another. So sorry, this should be an empty print. Okay, so let's see what this is going to give us. Let's run it. So now we could see that for every of our feature, like for example the symbolism, we have a total of the false columns, the false values. Rather, the false values had a total of 205. So they are not true values. And remember, it's not actually convert our entire data frame to true and false. And the true value represents a null. That's not a number value. That's a missing value. And the false, as I say, that an item is contained in that particular record. So now we can see very well the symbolism. So in the symbolism, there are no missing value. Normalized losses, we have a total of 164 non-missing values, and we have 41 missing values. So for the make, there's none. The fall tab, there's none missing value. The aspiration, none. Numbers of door has 2 missing value. Then body styles, none. Drift walls, none. Engine location, none. Wheelbase, none. Length, none. Width, none. Height, none. Crop width, none. Engine type, none. Number of cylinders, none. Engine size, none. Fuel type, none. That I'm talking about, that there are no missing value. But for the bore, we have 4 missing value. The stroke, we have 4 missing value. Compression ratio, no missing value. Horsepower, 2 missing value. Peak RPM, 2 missing value. City MPG, no missing value. Highway MPG, no missing value. And for price, we have 4 missing value. Okay, so that's the kind of analysis of every single of our features, all of them that have both the missing value and non-missing value. So based on this, we have a summary that we have a total of 205 columns, rows of data. For example, that's why you're seeing the highway. You could have 205 rows of data, and 7 of them actually contain missing data, and the 7 are the normalized losses, numbers of door, the bore, the stroke, horsepower, peak RPM, and the price. Now, how do we deal with this missing data? Now, there are different ways we can actually deal with it, but for this lesson, we're just going to use some method. We could either drop the data, that's to see, we can either drop the row or drop the entire column for each of those missing data. We can replace the data. So we can actually replace the data by either its mean, calculate the mean of that particular feature, then we replace every missing value based on its mean, or we can replace it by its frequency. So this has to do with, let's say, the highest occurring item within that particular feature, that particular column. So we can replace it by its frequency, and we can actually create a function that maybe the function that we're going to use to actually replace this data. So for this particular lesson, what we're going to be doing is that for some value, we're going to replace by the mean, some value we're going to replace by the frequency, and some we will have to drop the entire records. So let me just create a data frame again so that we can actually see this. df. Okay, so now for the following features: normalized loss in stroke, bore, horsepower, and peak RPM, we are going to replace the missing value with their mean. So we're going to replace it with your mean. Then for the numbers of the, we're going to replace it with their frequency, the highest occurrence. And for price, we're just going to simply delete the entire row. I'm going to explain why we're going to be deleting the entire row when we come to replacing the price, or kind of taking down the rows that have an empty price. So let's first of all start with the ones we're going to be calculating the mean, like for example, the normalized loss. So now let's first of all get the average, the mean of our normalized loss feature. So norm, let's just save that to norm loss. Then I'm going to do a data frame. So I'm going to get the normalized loss. Losses. Then I'll have to convert this to type of float so that I can actually perform. Get the mean. Now got the mean. Then I'll specify the axis. So I want that across the row. Axis is going to be equals to 0. So I'm just going to print the average normalized loss here. Average normalized losses. So that's going to be average norm loss. Okay, so this is going to give us the average normalized loss. So once I run this, we can see that the average normalized loss is 122.0. So for every of the missing value in the average normalized loss, like this, we have NIN, that's not a number, we're going to replace it with 122. So that's the approach we're going to be taking for the normalized loss feature. So every of its feature, every of its missing value, every of the single rows that has a missing value in the normalized column, we're just going to replace it with 122. So how do we do that? So what we just simply do is we'll just come down here. Let me just create another cell. Then I'm going to say I'm going to have access to. So I'm just going to have access to my normalized loss. Losses. And sorry. So my normalized losses, having access to that column, then I'm just going to assign it back because I want to replace all the missing value with the value of 122. So I'll just come here, then access it, normalize. Let me just copy this so that I won't make mistakes. So copy it and place it here. Okay, so we're gonna use the replace method. Then we're gonna not a number. Then we're gonna use the average norm loss. Okay, so this is going to replace every item that has a value of not a number is going to be replaced by this average norm loss, which we consider as the mean. So it's going to be replaced. So once I run this, and after I'm doing this, let me just run our data frame. So we can see very well, yeah, we have not a number, but we're going to see that that's going to be replaced with 122. Okay, so you could see very well all these values, all these rows that actually contain not number is now replaced with 122. So that's how we actually find the mean and actually replace all the missing value with the mean. So I just want you to just pause the video. Now what you're going to do is just simply you're just going to, because like I said, we are working with the normalized loss, the bore, the stroke, the horsepower. So let me just copy this to the screen, and these are the various features we are going to be replacing with their missing value. We're going to replace it with their mean. So I just want you to just try it on your own, see how you can actually replace, you can actually find out the mean and actually replace the missing value of the following. So I'm just going to place this within the screen so that we can see. So for broke, stroke, horsepower and peak RPM. So just pause the video and see how you can actually, first and foremost, get their missing value and see how you get the mean of each of these columns and replace them with the average. That's the mean in which you've gotten.